All right, my name is Stephen Gordon. Today we're going to be giving you an introduction to KubeVirt. KubeVirt is a project which is aiming to bring virtual machine management into Kubernetes. So I'm a product manager at Red Hat, based out of Toronto, Canada. My team is primarily responsible for what we call Kubernetes native infrastructure, which is effectively trying to look at what we're learning about managing applications in Kubernetes and seeing how we can apply that to infrastructure software problems, one of which is how do we manage virtual machines.
I hope you hear me now. So as I said, I'm Chandra. I work for FI Networks as a senior software engineer. Presently working for container ingress service project. So basically it is ingress controller and bringing container applications into the ecosystem and providing L4 to L7 services. And apart from that, it will have application services like WAF and providing better security. And previously started from OpenStack. I have an active user contributor. And now Kubernetes and projects like KubeVirt. Previously I worked with Cisco and other companies. So this is my short introduction. With that, I'll hand it over to Steve to start with the KubeVirt introduction.
Yep. So the way that we're going to divide this up is I'm going to start off with an introduction into the project at a high level and the current status of the project, and then we'll hopefully dive into the technical detail and even a short demo, time permitting. So as I mentioned at the outset, the goal of KubeVirt is to turn Kubernetes into a single orchestrator for containers and virtual machines. And of course, Kubernetes is already pretty good at the application container side of that equation. So really we're focused on the virtualization piece and how we can bring virtual machines into that ecosystem. KubeVirt started as a POC at Red Hat in 2016. We really only started getting serious about the project, though, in January 2017, which is when we actually open sourced it and created the open source project, which is Apache 2.0 licensed. Recently, I think in September, it was accepted into the Cloud Native Computing Foundation's sandbox as a project there. What that means, just from an intent perspective, is that we're looking to open up the governance of the project, make sure that it's a truly independent open source project, and continue to welcome more and more external contributors as we grow the project going forward. So in terms of our progress on that, you can see just some rough stats here, all the usual things around growth in commits, stars on GitHub, all that kind of stuff. The thing we're really looking at continuing to drive is increasing that split of non-Red Hat code contributors. So if you look at it right now, it's probably about a third of the contributors are non-Red Hat. We want to see that continue to increase. On the right-hand side, we've listed some of the users and contributors from other organizations which came out and supported the sandbox application recently. So when you look down these columns, those on the left with the check marks are people who are using KubeVirt today, and those on the right are those who are actually contributing to KubeVirt itself, or if the check is in brackets, that means they're contributing to one of the adjacent projects. So under the overall KubeVirt banner, we have a number of adjacent utilities, things like the containerized data importer for getting virtual machine images into the cluster that people also contribute to as well. And worth mentioning, we also hang out in the Pound virtualization channel on the Kubernetes Slack. So why KubeVirt? Why this desire to bring virtual machines into Kubernetes? So for one, when we started the project, we certainly already saw back in 2016, 2017, the growing velocity behind Kubernetes and the surrounding ecosystem as the place that people were increasingly looking to build and deploy new applications. But we also realized the reality that most people in their organizations have virtual machines that they're going to need to deal with in various ways for many years to come. So we really wanted to focus on how do we build transition paths for those users with those virtualization workloads as their mix of virtual machines and containers changes over time. And also to assist people who may want to decompose a virtualized application, but it's going to take them a little while to do so, and they want to do that within a common development environment. In terms of what applications are harder to containerize, so really here are focused on both some technical reasons. So certainly we're cognizant of the fact that many virtual machines, particularly even appliances you may be getting from another vendor, have limitations in terms of what is the operating system running inside that virtual machine and that application is certified on. So that's why we have focused on being able to run operating systems going back to the RHEL 6 kernel versions, just to give you a rough idea of kind of timeline of those Linux versions we can support, but also going back to Windows Server 2012 and above to be able to support those workloads that run on those as well. The other reason that things might be harder to containerize is, of course, business reasons in terms of just time to market and the cost of conversion compared to the relative return on investment. So I wanted to talk a little bit about some of the use cases we're seeing in the community. So certainly one of the use cases is simply I have some existing functionality in my organization that's running in a virtual machine, but I'm building new business functionality around that in application containers. So I want to pull that existing virtual machine into my Kubernetes-based development environment so I can work on those components of my application side by side and use the same CI pipelines and so on. So certainly that's one of the things we're trying to enable by bringing virtual machines into this Kubernetes ecosystem. Another use case is simply to support virtual machines that can't be lift and shifted directly to containers. So I have an application, be it a database, an existing ISV supplied appliance, that I want to bring in and run side by side with my containers, but not necessarily decompose. I just know I need to keep running it for the foreseeable future, and I want to bring that in as well, and we can certainly try and support that. Another one we see quite a bit of in the KubeVirt community, which is a little more interesting in some ways, or a little different to the first two, is as a way to run Kubernetes in what I would call the cluster-in-cluster configuration. And by that I mean organizations who want to create a separation between what they consider as their infrastructure Kubernetes cluster and the Kubernetes clusters that they're handing out to development teams, or even in some cases individual developers. So what KubeVirt is providing in that context is hard multi-tenancy between those developer-facing Kubernetes clusters. And the way that works is using, there is a cloud provider KubeVirt project that was provided in the community, and that's the way people are using it to connect KubeVirt up to the cluster API, so we can effectively use it to spawn new KubeVirt clusters or new Kubernetes clusters on KubeVirt. The final use case I just wanted to touch on, because we also see this from some of our community users, and it actually was a topic, at least for part of the discussion at the community meetup this morning, is the idea of bringing in virtual network functions and other virtual appliances to Kubernetes. So for those who are not familiar, virtual network functions is the idea which, as a communication service provider, typically I have some aspect of my network which is effectively living in a virtual machine. Often those virtual machines have fairly tight constraints on either performance or latency in terms of the functionality that needs to be exposed up from the hypervisor to make them perform appropriately. Many of those same service providers are currently investigating for the next generation networks how they would do equivalent things in containers first, but are cognizant of the fact that their existing networks are entirely built around VNFs, or at least increasingly built around VNFs right now. So there is interest in how they would manage those going forward together, but the challenge is that VNFs are quite hard to containerize, and they face many of the same challenges that those service providers are facing putting functions into Kubernetes, which is they need things like smarter handling of NUMA topologies in the node, and so on. So in terms of just some high-level features, and we'll go into this a lot more detail in some of the technical information in a second, but at a high level, we're aiming to provide an API for defining virtual machines, managing virtual machines. We do that as part of Kubernetes by implementing custom resource definitions. So we have a number of top-level custom resource definitions, including the obvious one for a virtual machine, but also a couple of others for various aspects of the virtual machine storage, and also for things like the idea of a replica set that includes virtual machines and so on. By implementing this functionality as custom resources, we do gain a lot of automatic integration with the Kubernetes ecosystem. So we do gain integration with cluster-level features. So my virtual machines running on KubeVirt are connecting to the same container networking interface plugins as my app containers, so they're on the same network, on the pod network at least. They're connecting into the same storage drivers using the container storage interface, and so on. And we also gain node-level features. So I kind of alluded to this in the VNF use case, but we are still using, both for our virtual machines and our app containers, the same CPU manager, the same multi-network provisions, multi-network aspects. We get the same capabilities in terms of huge pages and so on from the underlying Kubernetes management and orchestration platform. One underlying central tenet of the way we've been building KubeVirt is a focus on both ease of use, but also a Kubernetes native approach to both look, feel, and behavior. And what that means is that when we're weighing up a given traditional virtualization feature and how we implement that, we're always wanting to trend towards the most Kubernetes native way we can do that. And typically that means the way that will work for both app containers and virtual machines. Because typically whatever app it is running in someone's virtual machine today, they are going to have an app in the future that has some kind of similar requirement when it's running in a container. So if it needs a special device or some special logic around how we place that workload appropriately, we want to think about how we can make that work for app containers in the future as well. So really, somewhat selfishly, we're trying to improve Kubernetes itself, not just build something that kind of adds on to and goes around Kubernetes. So before we dive a little deeper, if you've already heard enough and you just wanted to get started, at KubeVirt.io, there are a number of getting started paths. So there is the Katacoda learning paths, but also if you wanted to spin up a cluster with KubeVirt on it yourself, there are buttons there to start with Minikube, Amazon or Google Cloud. The one thing I'll mention with the public cloud options here is that they are running KubeVirt in a nested virtualization scenario, which is not what we would typically see in real use. So in real use, we would typically expect that someone's running KubeVirt on a bare metal cluster, regardless of whether it's private, public, whatever. But for just getting started and kind of getting used to the interface and so on, running it in nested is fine. So feel free to go and kick the tires on that.
Yeah, thanks, Stu. That was a nice introduction. So I think now you got some idea about what is KubeVirt. So now we'll get a little bit more about KubeVirt. So the agenda of technical interviews, just go through the virtualization stack, and then what actually are the current scenarios, and what is the environment we need, and how KubeVirt is going to solve that, and a little bit introductions about the architecture and the components we use, and then followed by a short demo. So it's like within 5 minutes how to bring up the KubeVirt installation and just bring up your virtual machines. So it's a short demo, and if time permits, I'll give you the advanced networking demo as well. So we know that this is a typical Linux virtualization stack where we have a bare metal. On top of that, we have a hypervisor like KVM, and now on top of that, we are spinning up our virtual machines. So we for software virtualizations, we are using QEMU, and hardware virtualizations, we are using hypervisor like KVM. But when you want to run VMs, as said Steve, we should have some kind of mechanism where we are not running containers in the VM. We are launching VMs in the container. So this is a typical scenario where we have to take care the virtualization stack within the containerization stack. So how it is going to be, we are integrating the virtualization stack into the containerization stack. So this is a typical diagram how it looks. But who is going to solve this problem? So basically, KubeVirt approach this approach. The KubeVirt will be installed in the master as a controller, and it has an API-server, and the agent will be running in the worker nodes. So it will be talking to the both virtualization stack as well as the container environments, and then it is so like this. We can bring both virtual machines and containers in the same environment. Because the enterprise applications which are running for decades in the VMs or who have virtual editions as their solutions, they cannot simply migrate to the containers. For the companies who born in the cloud, that is easy and the development going on in the current is in the container space. But the companies which are using their solutions in the virtual space, they cannot migrate easily. They should have really two environments to support their solution space, which is hard to maintain, as well as the migration part is also very complex. Whereas if you have a environment where we can run our virtualized solutions and the containerization solutions, which is the future or the current development, and then we can slowly migrate to the containerized world, then it is going to solve the problem because we are in the same space and we are using one environment. So that is how KubeVirt is approached, and it has a different components. I'll explain in the next coming slides, but this is the basic architecture. It has a controller, it has an API-server, and it has an agent running in the worker nodes. So basically, we can divide the KubeVirt into these multiple components like API-server, Virt-Launcher, and the Virt-Controller. We have seen the previous diagram, and the Virt-Handler. And also, we are using libvirtd. So we'll go through the one by one. The one thing I would like about the KubeVirt is it is always, the design pattern is always keeping in mind the Knative. So they always don't want to be a virtual machines treated as like in the virtualization space. They also want to use the Kubernetes native applications like APIs and CRDs. So this API server supports the kind virtual machines. This is super cool. So we can provision virtual machines with the CRDs and just spin up your virtual machines in the just like you spin up the containers. So the Virt-api-server is defined to address those defining those kinds like virtual machine instances, virtual machine replica set, and node migrations. That will see in the next slides and also in demo. So, and also the libvirtd. This is a major component because with the help of libvirtd only, we are able to run the VMs in the container space. So why we are using libvirt is it supports vast variety of hypervisors like AVM, Xen, and VMware hypervisors. Also, it supports other operating systems. So because libvirt is a proven technology and it supports almost all kind of virtualization stack. So libvirt is also one of the main components of the KubeVirt we are using. We are just leveraging the advantage of the libvirtd here. So when it comes to the actual, how the action part, the Virt-Launcher is the key component, and it's just pod. When you install, when you trying to bring up a virtual machine, Virt-Launcher pod will come first, and then it will have the information what is going to be done, what kind of virtual machine you are going to spin up. So this will have two components like it will spin up. One is a volume controller. It can be a PVC volume controller, or it can be a container disk or any physical disk, or it can be a so when you have given a virtual machine image, so Virt-Launcher pod will kick off, and then it will kick the libvirtd, and then libvirtd will libvirtd daemon will be in action, and it will spin up the VM, just like you're spinning up the VM in the actual systems. So it's because it supports mainly KVM as a hardware virtualization, but it can also support the software virtualizations on top of any kind of a cloud provider or hypervisor. So there is a gap, like how you are dealing with the container networking and how you are dealing with the VM networking. Of course, virtualization has a vast features, and it has advanced features like networking. But when you bring up a VM within the container interface first, the tap interface, or we are using a CNI like Flannel, it will give an interface. But here we are launching a VM in the container. So we are using L2 devices like Bridge to replicate that interfaces in the VM. So how we are doing, the VNet interface we are creating, and the IP address, whatever the CNI is giving, that we are assigning in the VM. So that in that way, the Flannel networking or the pod networking will be applicable to the VM as well, and it will be able to communicate with the other ecosystem, that is the containers from the VM. So we are using a simple techniques, and with the help of L2 utilities, we are communicating the VMs from the VM to the container. So this is the basic networking, and we'll see the advanced part next. So the other part is it's a Virt controller. It's basically a controller for each and every object. Like if you have a defined for virtual machine, it's not going to be kickoff. We are not directly going to launch the virtual machine. Before that, we'll give the virtual machine instance. It is just like for OpenStack people, the flavor. So what we have defined, the flavor is nothing but a virtual machine instance. And with the help of virtual machine instance, the Virt-Launcher will know what kind of VM it is going to be spin up, and then actual VM is going to be a launch. So all these advanced components like replica set and node migration will be having some set of dependencies, and each will be have the controlled by the Virt controller. So Virt controller will control, and it will have the communication between the VMIs and VM kind of thing. So the final one is Virt-Handler. The Virt-Handler basically is the interface between the Virt controller and the Virt-Launcher. Whereas Virt controller is having the information about the VM specifications and all, the Virt-Launcher will see whether all components are running properly or not. So once the pod is running, Virt-Launcher pod is running, then it will kick off the actual VM. So it also handles the lifecycle management of the VMs, which is not actually, we cannot have this lifecycle management for containers. So this is one of the advantage if you run virtual machines in the, these containers. You can always just predefine in the dormant state, and you can start, stop, and you can just delete and you can update. So all this can be possible with the Virt-Handler. So it supports all kind of lifecycle management for virtual machines. So with that, I have just given a short architectural introduction to the KubeVirt. Now we'll see the demo part. So what the first demo is, we want to just bring up the KubeVirt installation part, as well as how we can install the KubeVirt in a short time and bring up a VM. So these are the steps. So first, I want to install the KubeVirt. So the prerequisite is you should have any kind of cluster, whether it is a Minikube also fine. You should have a master running. That's a prerequisite. And then I'll just going to give the I'm going to take the latest version of the KubeVirt, and then so this is the we can take from the GitHub repository. So presently it has the latest version 23. So I'm applying that. So the first thing is I have to install the KubeVirt operator. And then it will kick off all the pods which are necessary. And then we should wait for the pods to be running. Now it's running. So I can go to the next step. Okay. Thank you. Okay. So next step is we are installing the KubeVirt CR, and that is a custom resource, and that is the actual bring up all the components of the KubeVirt. Just now we have discussed. It will bring up Virt-Launcher and Virt-Handler, Virt controllers. So now we'll see. Now I'm going to install the Virt custom resource, and it is spinning up all the pods. First, it is bringing up the API server. and then it is bringing up. Then it will bring up the launcher as well as controller. So now we can see that so all parts are running. So this is like installation is complete. This is just like simple steps to install the KubeVirt and get up and running all the components. Now we'll see bringing up a basic VM, which is like we can take up the CirrOS image just like because it is a lightweight VM and it is good for it will spin up just like that. And I'm using a Virt. I have just now installed the Virt controller that is actually used for lifecycle management. So this is the YAML file I'm using. This is a kind virtual machine, and the name is test VM. And I'm just bringing up. I'm assigning some memory and the container disk image I'm using, but it's a remote, and I'm taking from the repository CirrOS. So it's using Cloud Init, so we can take advantage of the all the Cloud Init scripts we have. So now I'll spin up this. I'll apply this YAML file, and I'll try to bring up the VM. So I just applied that YAML file, and before it will not bring up the VM, but the status is false. So what we can do is we can just start the VM, and we can using virtctl command. I just started the VM, and now we'll see actually the VM is in the running state or not. And yeah, it is running now. So I'm just logging. You can use virtctl console command to log into the VM, because we have just spinned up. It is taking some time. Okay, it's booting. So here we go. Yep. Okay, so it's not even 5 seconds. So we have just launched we have installed the KubeVirt, and we have we have brought up a VM as well. So good thing is they are running side by side. We can, and basically it is having only one interface, that is a pod network, and yeah, it is able to ping the external network as well. So that's about that is first demo. So whoever want to have hands-on and get to know about the KubeVirt, just these are the steps you have to follow, and just bring up your VM. So this is about my first demo. Do we have time? Yeah, I think we can go for the second demo as well. So next, this is like for the VMs who need multiple interfaces. This problem we have when we are bringing up the containers, but for virtual machine, this is a basic feature. So when we are bringing up, when we want to bring up a virtual machine with multiple interfaces, that is not supported presently because of the limitation. We have only the CNI, the Flannel will have only one interface, but that can be solved using the Malta CNI. So now you can see here, I have a YAML file, which is virtual machine instance, and I have defined 3 networks here, and I have actually bringing up the image from the. Okay, before this, I can show you one interesting thing. Which is actually, okay, I'm not connected. Yeah. So before going for the demo, we want to have a short introduction about what is Maltus. So Maltus actually, it arbitrate to bring up multiple CNIs. So for the applications which need multiple interfaces, we can install Multus, and we can specify what network interfaces can be treated as a Multus, and that interfaces can be connected to the other side of the containers, talking to the external world or management IP or management network, whatever the needs based on the networking part. So this is one thing, and when I started exploring this KubeVirt project, one primary problem I have faced is uploading the images, customized images, because VM images, just now we have shown is that we can take them, ZeroS image or CentOS image, we can take from the cloud images. But when you want to bring up your own image, right, you should, the customized applications, you want to have it in the local disk. So I found this, Docker command is very much useful. You just, make images, container images, using a Q-Core2 images like VM images, and just upload it to the local container disk, and your image, container image is ready. So apart from that, you can use persistent disk like PVCs and PVs, but if you want to have explore quickly and bring up your own application or own VM, you can upload it to the container disk, and you can just start using it. So that's what we are doing here. So I have just uploaded that CentOS to my local registry, and then I'm pulling that image with this command. So it's as simple as that. And then I have defined my specifications like memory and all, CPU. And now coming to the interface part, previously we have shown only one interface. Now we can see the three interfaces, basically network 1, network 2, and the pod interface. Now we'll talk about this pod interface, and I have also defined the networkings. So here the network 1 is my application network 1, and the network 2 is my application network 2 for different purposes. And the pod network, I'm not specifying any network so that it can use the default network that is a pod network. In this case, I'm using a flannel network, and for other to bring up other networks, I'm using a Multus network. So this is my typical YAML file. Through this, I can bring up multiple interfaces. I can start using multiple networks. Okay. So there is one interesting thing. When you bring up your application with multiple interfaces, right? If some applications, the default interface is pod network, that is ETH0. But if you want to use your own network, like management network, as a ETH0, that is overwritten by the pod network because of the default behavior. So in that case, by changing the order, like I did here, I have specified the pod network as a second interface, and my management network as the first interface. With that, you can use ETH0 as your management network, and you can always use your pod network as a second network or second interface onwards. So with this, we can solve our own networking problems by just simply replacing the order. And now, okay. So because I have already running this, I'll just try to log into that machine and see whether it really attached the three interfaces or not. Okay. So this is my CentOS VM and my customized CentOS VM, and yeah. So here you can see all the three interfaces, which is like ETH0 is my management network, and ETH1 is the pod network, and ETH2 is your for other like external network or public network. So with this, with this demo, I think we have completed the networking part. I think we should have some space for questions.
So I have the one.
Yeah, sorry. We have a last slides. I'll hand it over to Steve again. Yep.
All right. So just quickly, in terms of future plans, in a sooner to later rough order. So I mentioned kind of the core goal is to be able to run traditional virtual machines that people already have. In many cases, that means better support for workloads that are exacting from a determinism or a performance standpoint. So certainly improvements around CPU pinning, NUMA topology management, IO thread pinning. All of these things are also things we're trying to improve in Kubernetes for general application container workloads. So that ties in quite well with things that are happening in the broader community. We are also looking to take advantage of storage-assisted snapshots and cloning. Particularly, this becomes useful if you think about an end-to-end flow where you want to take a backup of a virtual machine and you have some underlying storage subsystem that can assist you with that and performing it in a performant manner. We're also looking at forensic virtual machine capture. GPU pass-through is actually out of order here. So NVIDIA have contributed GPU pass-through in a recent release. So that is there now as well, although we're still finalizing some of the documentation around that. Policy-based live migration and additional live migration modes. And finally, hot plugging is something that we're interested in for some of these traditional workloads as well. Again, in terms of the Kubernetes native approach, many of these things are areas where we're trying to improve Kubernetes as well, not just the KubeVirt project on top of it. So for those who want to go deeper, there is a KubeVirt deep dive session tomorrow at 10:55. That'll be in room 1AB, and some of the engineering folks who are contributing directly to the project will be doing that deep dive session. So I suggest anyone who's interested go and catch that. And kind of as alluded to in the title, that will be one of the NVIDIA developers who'll be participating in that session as well. So I think that's all we had for today. I think we only have like a minute for questions. We'll try and take a couple, but what I'll ask is if people want to catch us, we'll be outside the room immediately afterwards as well for a little while in the back there.
Yes, yep.
Is there SPICE or VNC remote console support? Right now, we have the serial console, we have VNC. We do not have SPICE because SPICE and the number of ports it uses poses some interesting challenges from a Kubernetes networking perspective. But we also, if you're running a Windows VM, you can expose the RDP port as a Kubernetes service, and that works just fine as well. Any others quickly? Yep. Can you throw libvirt XMLs at it? No. Although you'll find the top-level API definition for KubeVirt is very similar to the libvirt domain definition. So you could translate it relatively easily that way. But we don't currently have a way where it will just ingest the libvirt XML domain as it exists today. Yeah. OK, thank you all. We'll step outside if anyone wants to follow up with anything else. Thank you.